All right, thanks Priscilla for letting me record this portion of office hours. We're talking about isotopes and how you get the mass that goes on the periodic table. So what we're talking about is we want to start with the sort of how you learn to do an average in third grade. So Priscilla, you told me this a second ago. How did you learn to do an average when you were in third grade? If you wanted to like average the numbers 5 and 7.
You would add them together and then divide by 2 since there's 2 numbers.
Yeah, exactly. So you would say, okay, I'm going to calculate this average as the average is equal to 5 plus 7 divided by 2. And this is correct. I want to change that a little bit for us right now and write that in a different way that I think would be a little bit more helpful. And that would give you the average value is 6, by the way. So here's a different way that you could have written that down, which I think will get us to what we're doing in this problem. So the average is 1/2 times the value of 5 plus 1/2 times the value of 7 is equal to 6. So sort of in words, what we're saying here is that there are 2 values, there are 5 and 7, and each one is going to contribute half to the final answer. So rather than adding them both up and dividing by 2, you could take half of this number and add it to half of this number, and that would give you your average. And if there were 3 values, it would work pretty much the same way. You would, let's say we were taking the average of 5, 6, and 7, then you would average, each one would contribute 1/3. So 1/3 times 5 plus 1/3 times 6 plus 1/3 times 7 would give you your average. And you would just say each one is contributed by 1/3. So 1/3 of 5 plus 1/3 of 6 plus 1/3 of 7 would add up to our overall average. All right, so hopefully that makes sense. We're almost there to the problem. So let's get rid of this and let's make one more change to our equation. Rather than fractions, let's use decimals and say that essentially, if we said half there, oops, I'm still erasing, let's undo that. If we said half there, that we could just as easily take that half and call that 50%, which would in decimal form be 0.5, right? So I could rewrite this equation 50% or 0.5 times 5 plus 0.5 times 7, and that would still equal 6, right? But that would be the same exact thing as saying half times 5 plus half times 7 is equal to 6. 0.5 times 5 plus 0.5 times 7 equals 6. Does that make sense, Priscilla?
Makes sense.
Okay. So that's key because these numbers here is what's going to change in our next equation. In a weighted average, we can change the weighting factors. So instead of 0.5 and 0.5, they don't have to be equal amounts. They'll be the natural abundances of each element in nature. And so we can actually just get rid of this now and go to our screen. So would you mind, I'm going to stop my share. Would you mind sharing your problem now?
Okay.
So the general equation for this when we're doing a real problem is like this. The weighted average, which is the number that goes on our periodic table, the weighted average mass of the element is going to be equal to the natural abundance, that's like our 0.5 or 50%, times the mass of that isotope plus the natural abundance of the next isotope times the mass of that isotope. And then this could go on and on depending on how many isotopes there were. Here, it's relatively straightforward. The two isotopes are potassium 39 and potassium 41. So we would take the abundance here and plug it in. We plug it in decimal form. So that would be 0.93258, not percent form, but decimal form. We would take the mass that goes with it and plug that in here. Then we'd take the abundance of potassium 41 and plug it in there, and the mass that goes with it and plug it in there. And that will give you your weighted average mass for potassium. And so what it's asking you to do here is just you know, select the steps that you need to do. And that would be multiplying, like we were doing here, the abundance times the mass. So I'm gonna have to clear the screen. But yeah, that's what you'd be choosing is the abundance, the 0.93528 times 38. That would be one of the steps. And then the other step would be whichever one is multiplying point. Not the one you selected, the 40.96, the atomic mass, but what's wrong with the abundance number there?
It's not in proper form.
That's in percent form, and you need the one over here that's in decimal form. Yeah, exactly. So that's how you go about it. I'm going to stop recording. Thanks for letting me record. If I can figure out how to stop recording.